this. Like, I have Orion's belt that comes overhead every night around like 9:30, 10 p.m. where I'm at in Vegas. And that's when I try to like actually reconcile that for myself, and it just kind of hit me. I'm like, there's no way we're making all these movements. Like it just doesn't comport like on its base, right? Like I would at least start with geocentrism and just kind of look into that, the idea
Yeah.
that we're stationary and that the universe moves around us. And then you also take into a fact like that satellites, use real inertial forces, right? And treat Earth as a stationary, object. They use real net like inertial forces. Like they basically treat as if the Earth is non-moving, stationary, and that the universe is actually going around the Earth. I mean,
And
it's just
Yeah, actually, so
insane.
so that's the type of stuff that I'm most equipped to talk about, like even more so than measurements of the
Curvature,
radius of the Earth beyond just,
right?
repeating back the shadow experiment stuff, which hinges on the parallelism of sun rays. And I realize I'm not really sure, how to, from first principles, justify the parallelism of sun rays. So I'd have to go back to that. But regarding parallax, we do see some parallax over the course of a year. I don't know how strong of a telescope you need to see it. But there is some relative shifting of the positions of certain stars with respect to other stars that
That,
sort of
that
has the characteristic of parallax motion
oh
on
fine,
it.
but it's not mutually exclusive. You know what I mean?
Yeah.
The heliocentrism versus geocentrism. One of the biggest heliocentric claims is, stellar aberration.
Mm.
And then you look into stellar aberration and, you know, even granting them that, it destroys the relativistic paradigm too on top of that. Like there's just so many layers to this, ZZ. Like you're just gonna have fun. You're gonna have fun going through all this information and
Yeah.
making up your own mind. Like, and I look forward to seeing like you ask more questions and stuff, bro.
Sure.
So
Um, well, on the stars going around the galaxy one, I mean, if we're moving with the other stars around us, then just reading off the velocity of us around the galaxy isn't the number to use for what our relative velocity is for the stars next to us. Like the analogy would be like, if you're on the road going 60 miles per hour and someone goes by you at 70 miles per hour, it's only a relative difference of 10 miles per hour. So I don't know the details of all the stars around us, but they are in the model, going the same way around the galaxy as us. And the further away something is, the less
I was gonna say that's
velocity
why they
between
say
you and
it's so
it.
far away though. Like
Yeah,
that's why they say, oh, it's just trillions of light years away,
well,
right? Which
years for the nearby ones, but but trillions of miles is the point. Is
trillions
that
of miles, right?
yeah
Light years
the
away, and like you ever heard
yeah,
of the inverse square law?
yeah. And that
How is
is
that reconcilable, right? Oh, they have to make these stars gigantic. It's really absurd, bro. I'm not saying, I'm just saying like on its face now looking back
mm,
at it, it's so absurd. Like they tell the story, right? It's a cool story, man. I love science fiction. Like don't get me wrong. Like I was a space nerd. Michio Kaku, Neil
mhm,
deGrasse
yeah,
Tyson, Lawrence Krauss, like all these people that I used to look up to, like in astrophysics, and
yeah.
you realize that they're just telling like a story. They're just the high priests of today, and then the doctrine that they're pushing is this cosmological paradigm that you're not special. That the Copernican principle basically states that the Earth can't be in a special position. You know, there's a lot of philosophical implications to what they're teaching, on it. Once you get deep into it, like I know I'm
Yes.
skipping a lot, but there's a lot to it, man.
well, they
Yes.
self-admit I've been trying to get in for a sec, just real quick.
Of course.
They self-admit the time dilation, but yet don't apply that to how light would be affected. We've got multiple repeated tests for like the ether field. I don't like the word ether or whatever because of a lot of people have read about it and decided it's a conspiracy or whatever. But no, they classified the second test that was done like a high budget test done in the Navy and the Air Force. So two different tests. budgeted by our military, and they're both classified. So they know there's a different field. There's a reason they've been looking at gravitational A and B waves with LIGO.
Oh,
There's a reason they built CERN. It's not because they want to know. They already know. They're trying to figure out how to optimize it.
Great
So
point.
this field, right? So this field they know about, they're just unwilling to admit it. And you can see it. Like they're at a weaponized phase of trying to call people stupid for asking good questions. And
And
it's
speak absolutely. They want to make it look so bad you don't touch it with a 10-foot pole. And speaking of weapons, ZZ, this is
mhm.
probably one of the foundations for war, because with
Oh yeah.
with no creator, you can go to war.
No
Uh,
accountability for your actions, right?
I gotta crash and go to bed soon, but I'd love if I could ever get in on like a one-on-one discussion or debate because there's so many different things to talk about, but I feel like I lose track easily as like what
We're
point
all a
we're
little
on.
ADD in here too, bro. There's
I'm
so much information.
very ADD. I'm very ADD.
Real,
But
real quick, ZZ, hold
yeah,
on. Before you go, I want to ask: Do you think words are important?
how else would we understand each other? I don't, yeah,
Okay. Do you consider yourself an academic?
yeah,
Have you ever looked up the definition of academic?
no.
You
What does it
should.
mean? Good. See, look at all the not look at all of this knowledge that is just like, yeah, no, I don't know this, I don't know that. You know, people are bringing up. I don't know
We
what the
love you.
definition of
Yeah, I
academic
love
is.
how open you are to it, brother.
Yeah,
Hey, I added you as a friend. Do
thanks,
me
man.
Yeah,
a
y'all
you're
have
gonna
the
walk
nicest
down.
debate.
slight favor, man. Whenever you get a chance, because it's a nice, well-produced documentary, watch The Principal and come back.
Sure.
Like
Y'all have
seriously,
the
that one.
nicest debate.
This is yeah, yes, it would be the friendliest if possible one. That's what I aim for here. Well, I don't want to come out hard on something I don't actually know.
That's
So
a
I'm pretty
respectable stance, brother, and I appreciate that.
cautious on things. I guess the only last thing I want to say before I log off for the night is though this thing keeps coming up though, which is the idea that like humans wouldn't be special in a model of the cosmos where like Earth is just some planet around some star in some galaxy in an unimportant same as everywhere else part of the universe. And I don't know, like this really gets into philosophy here
Hmm.
of like, is that the defining thing of what makes humans special, or is it something less tangible? I mean, isn't like the thing that makes us special and sort of a metaphorical center of the universe, regardless of cosmology, is we are the only observers of our level of consciousness that we're aware of. So I think it's sort of more of like a meta discussion of,
Dude,
what
watch
does it
The
mean to,
Principal, bro. That's so. It's literally the relevant question in that documentary. Like literally that question. Highly
Well,
recommend it.
you know?
well, the answer to does a bear shit in the woods if no one's there to see it or hear it? Well, the answer is no. It never becomes particles. It's a wave. No one observed it. It's a wave.
Well,
And once you realize that, and that they prove that in the lab,
yeah, and I feel inclined. I'm gonna these types of there's like a high level discussions in terms of like the relativity, the relative aspect, and
Mhm.
that kind of, if that's what you're interested in, I'm gonna invite you to Ether Cause, do presentations every Tuesday.
Cool.
um I threw you an invite there.
I got real obsessed with some of the tests they did with the foil, the different types of gold foils,
I'm not sure what
and
that is.
well, it's the gold slit experiment. Google it really fast if you
Where,
haven't. You can
where,
read.
where'd you throw the link in?
Oh,
Just
I
want to
sent
click
it
on
to
it.
you.
Oh, sent it to me. All right, cool. Tight.
Yeah.
I'll check that out. Well, thanks very much, and um, try to gather up my thoughts on things more quickly.
Yeah, bro,
Sorry,
go
more
obscure.
clearly before ever having like a real, kind of focused discussion on anything. But thanks for the conversation. Peace.
Thanks for being cordial and cool, man, and
Yeah,
open. You have a
yeah,
great
yeah.
night.
You too.
You probably know about the double slit experiment, man. You're just not thinking of it. There's no way you don't know about it.
Oh, I mean, that's That's another
You're
thing
bringing
that's
people
like,
to the dark side, basically.
no, Roohif. Your name literally means to put people back to sleep, so get out of here.
Basically, it was the first.
Roohif, is that what you're
experiment.
doing? Your globe Roohoofinalling people up in here? Why did you change
It
the
ain't
name?
working.
Yeah, have you popped roofies lately or?
No, I got my original account got nuked because I was mod on Shane's server.
I'm just joking.
That doesn't explain why you choose the name Roohif after you got deleted.
Because I'm 12 years old inside.
Well, your name used to be Roohif, and now it's Roohifinol, which is which is off of roofies. It's kind of sketch,
Gio,
but
that's a spoon in a bowl. What is that? What you got? Oh no, that's Roohie. It's Roohif. Never mind.
I have an idea. Roohif, why don't we start a petition to get the National Geographic and PBS videos off of YouTube, or at least with a warning?
I've tried
Roohif
contacting.
yeah, go ahead. You tell your story on that. You contacted the whole team, right?
Yeah,
Wait, what?
I've tried to
What's going on?
contact pretty much everyone on the PBS, like the whole production crew and the actors and whatever else, and I got zero response.
Fill me in. I'm missing something. What happened?
Well, you know the PBS video where the helicopter goes behind the curve, right?
What?
I am unaware.
Yeah,
Oh,
they did a flat Earth
crap.
debunk on PBS.
Yeah.
Well, this
let me
is like
find
the PBS one where they clearly faked it, and even the Globe Earthers agree it's completely faked.
Yeah, it's
Where
like one
they
of those bullshit like ghost hunter videos. You know what I mean? They just soundbite everything.
no, so I mean, I guess, but they tried to. They basically. Well, do you want to explain it, Roohif? Or, I mean, it's kind of a classic. I mean, a lot of people have gone over it for years, but basically they make it look like the helicopter went below the curvature, and they cut in the same footage to make it look like it went below the curve, even though it didn't. It's just complete fakery on every level.
Yeah, I
Yeah,
tagged
exactly what I
Beasticles
said.
in
Like ghost hunters.
I tagged you, Beasticles.
I'm watching
Yeah.
it now.
And then same with the Nat Geo. It has 6 million plus views and it's still online. And they use an asymmetrical flag. And then they outright lied. It was an optical illusion. Otherwise, they would have used a symmetrical flag.
I mean, I would go after like National Geographic. I would go after everybody if you're gonna do it.
Yeah, they should take these videos down because it's deception. What kind of the thing is though, Nat Geo is owned by Disney, and Disney is owned by BlackRock and Vanguard. But yeah, it'll be difficult to probably take those videos down unless there's like some sort of mass petition. But
So that's how it is, Roohif. PBS can just lie to the people about curvature. They just get away with it and can't do anything about it.
Apparently.
Yeah.
Yeah. Looks like it, doesn't it?
great question.
Yo,
how
History
could-
Channel pisses me off.
So anyone asking how could they lie or anything like that, it's just right there. They just do it. Everybody believes it, and there's no accountability to the public broadcasting station, PBS.
Oh wow, they literally it's the same clip because the ducks.
Yeah,
Yeah.
you can. It's blatantly obvious. It's
Wild.
like some retarded shit from the Sci-Fi Channel, like a ghost hunter shit. That's why I made
Yeah,
that
but
joke.
with enough quick edits and just the average attention span, there's curvature.
So there's two
Wow,
possibilities. That was
So
by
that's so
accident.
deceptive.
You
Yeah,
gotta
was
see
that
in
by
like
accident
90
or on
frames
purpose?
to miss that.
Oh, sorry. Go ahead. What'd you say? Taking back?
Oh yeah, my apologies. Go ahead, Tank.
No, you go.
Very good.
Oh,
I was just trying to get in, like a little stupid comment.
okay. I was just gonna say. Now that leads us to two possibilities, right? Or whatever. Was that on purpose or by accident?
What do you mean?
The
It's
birds.
clearly faked, right?
There is no
Yeah, but-
chance that it's by accident.
So
Yeah, it's
there.
definitely not by accident.
I agree.
Or they don't take the topic serious enough, so they're like, we're not going to put the money into doing the real clip. We'll just bullshit it and get it done.
No, that's purposely being deceptive right there. Even Roohif agrees with that.
Yeah, absolutely. I'm 100% with this. I'm just saying, like, it's possible they're also that stupid, right? Like, you look at the
Yeah.
producer team and their budget, they're like, nah, we're not taking this that serious. Like, we'll bullshit it,
And,
right? So,
and and then the person doing the editing didn't catch it, and the editor just didn't catch it.
yeah. I mean, that's just. There's multiple things that were wrong with that video. I remember.
Oh yeah, and then there was a female scientist that supposedly said that she is not a scientist when she
Cat
was on a
Bobineau.
YouTube video claiming to be a scientist.
Yeah, you can look her up.
And I mean,
Yeah,
some of you guys have seen my.
she's just blatantly lying, right, Roof? Like when she says
Yeah.
she's not a scientist and she says she is, well, she's just playing roles. But so that's another thing. She's playing roles, but they don't really say, "Hey, she's playing a role." They make it look like she's legit. So again, to the unsuspecting person, they may just think, "Oh yeah, she's a scientist," and then they just go on with the thing. And lastly, I was going to say one main reason to fake this is because there's no curve. That's the most obvious reason.
Sure.
I
It's
agree.
the same strategy they pull with like the History Channel, like Ancient Aliens. They do the same production strategy, right? It's clipped quickly into stuff. It's edited just sneaky enough to where things are connected that shouldn't be. They'll take 5 professionals in their fields and interview them, and just soundbite them all on a line, like like this guy, this guy, this guy, this guy, all like creating a whole new sentence, and it's just a joke.
Ancient astronaut theorize.
So,
Forgotten
Roohif,
rejoin Geo.
you actually wrote to the BBC about it's scam or it's edited?
Is that better?
Roohif did.
Yeah, you actually wrote them, Roohif?
Yeah, I hit up most of the production crew, all the ones that I could find on LinkedIn, and I tried to hit up the teacher guy and Cat Bobineau.
I am actually impressed. I think that you are doing it because you are smart enough to realize this video is actually making new flat earthers. But I'm actually impressed that you are doing it or that you did it.
Yay.
Yeah, I agree.
Oh, excuse me.
You should document the conversation and post it on like a WordPress or some shit.
Could go back in LinkedIn, see what I got.
That's what I've started doing. Like any stuff I try to go and like debunk or research, if I communicate, I just try to document and record everything and store it.
Well, Roohif's favorite topic is refraction. So Roohif, how is it that when we use infrared and you cut out the refractive index, right? It's the least
No,
amount.
you don't.
It's the least susceptible to refraction, and then you see further. How does that compare with refraction, making things look flatter? Just want to know.
Beast,
the
why are you
difference-
doing it to yourself?
Isn't that
Well, he
frequency?
just ate. He's got a full belly. I'm
Isn't
ready.
that just because of that's just because of frequency? It doesn't have as well. Hold up. That's just because of frequency, right? Like
The difference between infrared and the blue end in terms of how much it bends is hardly anything at all. The difference is negligible. The reason why we use infrared is because of scattering. It's far less susceptible to scattering. That's why
it
you
has
see
way less
clearer.
reflection vectors because of the wavelength.
So we can see further.
You can see with better clarity.
Mm.
You can't
Well,
see further around the curve, no.
Well, you would get just way more information, if that makes sense. That's true, unscattered. Right? Anything else, you'd have to look at the data to really know. But
yeah, you can see more clearly.
So if you can see more clearly things that should be obstructed by Earth curve, which means less refraction because you're using infrared, how does that compare?
No. Like I said, the difference between infrared and refraction is negligible. I've even got a slide. Let me post a slide. Hold on.
Swear to God, Roohif, if you post that stupid balloon chart, I'm done. That's it.
It's
I mean, no,
related
that's
to
a
the balloon
thing.
chart.
Like because, like
I know
especially
you're gonna do it now just to spite me.
especially like
it's,
distances
this
like
one.
the James Webb
Ru-
telescope.
There you go.
Roohif, we're gonna
Negligible.
toss you off the edge if you post it. Any
No, I didn't post the graphs. There you go.
All right.
Does infrared let you see further? No, it does not.
I would take that up with the military, bro.
Okay.
That's why they use infrared and laser targeting, but whatever.
Cartoons. Who's White Rabbit? Who's this clown? Fucking commie.
Well, it's been real, you guys. I'm gonna go to bed.
Good night.
Great conversations tonight. Gio, I'll try and find some good emojis to add to your little lexicon. I'm gonna find some good ones.
Oh yeah, I added a few. Yeah, if you want to. Always fun. But yeah, bro. Have a good night. Cheers. Yeah,
Good
it was
night,
great.
Gio.
Yeah, you too. Good night.
Good night, everybody.
See you.
Good night.
What time is it for y'all?
Should we tell Geo that White Rabbit's muted?
No.
Okay.
Yes, it is Blartek. Yes, it is. You're gonna call me a Jew now?
Or commie?
Or a commie Jew?
So all right, let's come on. So what is your actual why do you think PBS actually did that?
My
Roohif?
guess is they had shit footage on the day and that they didn't do the right calculations either. Yeah.
So you think maybe they just didn't have enough footage? They figured they'd fudge it, maybe just a shortcut, and just kind of cut the video in and say good enough for government work, and just
Good enough for
sign
the
off
sheeple,
on it.
Geo. Good enough
Yeah.
for the sheeple.
And it's like
Well,
they don't
don't-
even see it, they don't even have to see it as an accurate scientific thing. It's just sort of a BS like kind of surface level flashy thing that doesn't really. There's no accountability because they're just a production crew.
Yeah.
Entertainment
Right.
value.
Yeah, so your theory is not that the clandestine, levels of secret societies did this on some level. You think it might have just been more surface level, shortcut kind of stuff. Meaning it's not that they know the Earth's not a globe, was what you would say, or do you think that there is a potential? Well, I know that your whole viewpoint, obviously, you think it is a globe, but I'm just saying,
Yes.
you think that you don't think that there was any purposeful. Is that I'm trying to steelman what I assume your viewpoint would be, that there was just a mistake or something. Is that what you think?
Yeah,
Or
maybe the helicopter wasn't fully below the horizon. Maybe it was high refraction that day and they didn't get the footage they needed. Who knows? Can we go on camera, Blartek? We both go on camera at the same time?
Oh, you get Blartek on
No.
camera.
I
Jeez.
won't.
You're asking a lot there.
Yeah, I know.
Hey guys, total off topic. Do you know any good online YouTube downloader? If I want to download some videos from YouTube, like some good site or program.
I ended up just downloading 4K downloader and it works pretty well. So the online ones tend to be pretty shit.
If you look in Brave browser, there's plugins that are really reliable.
Well, here's all the nerds coming out now with advice.
Yeah. There's an ad blocker too you never have to watch another ad again. I love that.
what's the one you said 4K downloader, Roof? That's
Yeah,
the one you like.
Yeah, I'm looking at
Yeah,
it right
that's
now.
right.
It's free or you have to pay?
Free. You get like 10 downloads
Nice.
a day or something. Yeah.
Nice.
Yeah, 4K video downloader, man. It's not good for just YouTube. It's good for everything. BitChute, Facebook.
It's four number kdownload.com.
Yeah, 4K download.
Nice. Thank you.
It's good for everything. basically almost everything.
Did it do pretty good on audio too?
What? I didn't
Is
hear
the
you. What?
audio is the audio pretty good?
Yeah, you can high definition, and you can transfer you can convert it to MP3 or whatever you want. There's many file formats you can transfer stuff. Convert video to MP3.
Is it 4kdownload.com?
Yeah.
I better start using that one. I've been using a Brave browser plugin, and the audio is always like it's like hit or miss on the audio for some reason.
Yeah, but with the infrared that he was talking about before he left, I don't know, man. You can look at images without, you can regular resolution, regular spectrum. Then you can use infrared spectrum and you can see way farther, man.
Clearer or less obstruction? Less bottom-up obstruction?
It makes things that should be completely obscured by the horizon resolvable just by using the infrared spectrum. That's why the military uses infrared spectrum in all their aircraft, basically.
Do you have an example?
Oh yeah,
Yeah, I was gonna ask you that.
there's plenty of them, dude. And some of the longest images that we have on record are infrared footage.
Yeah, we've got the guy that's on top of Canigou looking across the Alps. Are you suggesting that there's less hidden than in the visible spectrum there?
Within reason, right? On top of a mountain, it's going to be negligible. But when you're on near sea level, 500 feet above sea level, 1,000 feet above sea level, it's undeniable that infrared resolves things that should be completely obscured by the predicted radius of the Earth.
If you have an example, I would love to look at it.
Oh yeah, dude, you act like, dude, come on, bro. This isn't your first rodeo. You act like you've never seen an infrared. Come on, bro.
I've seen plenty in infrared, and I say there are 0 examples of what you're saying.
Yeah, right. I don't believe you.
Okay.
This is your first day here, bro. You've seen the infrared photography, dude.
Yes.
Stop playing dumb.
I'd like to see the difference.
I think I've got a couple of Jay Tolan ones I can grab screenshots from. Hold on. Where are we?
Even though you are right between the spectrums, red or blue, green, and red. Red is the least prone to refraction or scattering, and infrared is even less prone to scattering and refraction. But when you consider the distances, right? Because like when you're talking about like across your room, dude, it's it's so negligible. It's irrelevant. But when you're talking about 10 miles, 20, 30, 100, 300 miles, that little bit that initially is negligible, then it compounds and then it becomes significant over
No, it
distance.
doesn't.
Yes, it does.
Well, I've got the figures. I've done the calculations. It doesn't.
Well, with James Webb Telescope, it does.
Sorry?
With James Webb Telescope distances, like the Hubble Space Telescope, like how far these the light wavelength are traveling, you're getting that extreme effect
Of less bottom-up obstruction looking at galaxies.
Well, it's really it's just the way it's because the wavelength has less reflection vectors, so it allows it to pass through more obstruction. It's that simple, and you can look at the data to see that. But it's also you can see it now. We have more modern telescopes that are being affected by it. They admit to it.
Hold on. James Webb Telescope is in space. Why are we talking about bottom-up obstruction for a
You gotta
space
just it's not off topic. You gotta just
Yeah.
you gotta just shift it. You gotta just get it back on track. Sorry, bro, it's just not on topic. I mean, unless you're trying to link it somehow.
Yeah,
but...
you got me. You lost me when that came up.
How about
It's pretty easy
do
to
a
lose you guys,
Deutschler?
apparently.
How about I do a U Deutschler of Jay Tolan looking at San Jacinto? Is that a good idea? I'll do it anyway. Give me 5 minutes.
Yeah, Roohif, do you know what I'm looking for right now? I'm still looking for the first and second videos of Earth from the moon.
You guys even know what topic we were on?
Infrared, were we?
I thought we were talking about infrared.
Lion. When I look at infrared, I think refraction is caused by two things: reflection and bending of light through water particles and other particles, mostly water particles. And infrared only dissolves the reflection part. So there might still be lensing effect that causes bottom-up compression or distortion. Yeah, that's my take on it. That's what your infrared does.
Wait, I had a hard time. Can you repeat that? I'm sorry. Can you repeat that again?
Looking at different infrared pictures, there's another guy, I forgot his name, who made an observation from Wales to the mountains higher up in England. And no. Yes. I can look it up, but what I see is that refraction is caused by two things: by the light going through water particles and bending that way, but also by reflection, which is the same as mirroring. And UV infrared only dissolves the reflection part of it. So the lensing part that is causes also bottom-up compression is still intact.
The photographer is Andrew Bailey. I've posted the original in the chat.
So you're saying that we're only dealing with reflection, internal reflections here, and mirroring? Is that what you're saying?
Yeah, I'm saying that part is dissolved by infrared. You can see very convincing evidence of it because the water surface is always black, so all the reflection is gone.
Okay, that's good. But it's not just internal reflections; it's also scattering and refraction in general. Infrared is less prone to all three, right? Including attenuation and diffusion. And so, like, for example, I'll give you an example. When the sun is setting and when the sun's near the horizon, do you know why the colors shift to orange and red? Because of light attenuation. Because the warmer spectrum, red, orange, infrared, are less prone to all types of refraction. That's why when the sun sets, everything goes red and orange. Same thing with the fall colors of the sun, because the sun's closer to the horizon. When the sun's closer to the horizon, it's the light rays that are traveling. And don't correct me on that. I know people are gonna be like, oh, it's not. Well, does light travel? It's propagating, whatever, right? It's propagating. The light, when it's propagating, it's traveling through a denser atmosphere, right? Because near the surface of the earth, it's denser, right? And because of that, there's more evaporation. So you got the sea evaporating, you got heat rising from the surface. There's all types of stuff with humidity and gradient densities that causes refraction, right? That causes light to bend towards a denser medium and never gets a chance to reach your eyeball. So, like, the light that's the most prone to refraction is actually the blue spectrum. And then after the blue spectrum it's green, and after the green it's red, and then infrared. So out of all the colors, infrared is the least prone to refraction. and red. That's why everything looks red. It's not just internal reflections, brother.
No, but my main point was that there is still bottom-up compression. That's my main.
Not as much though. Not as much.
I don't know.
That's why things are resolvable. The whole thing's resolvable. Yes, there will still be bottom up obstruction. But if you don't use the infrared, you won't see the objects at all. In some instances, at all.
Yeah, that's what I mean. That the reflection is filtered out. Yeah.
Now, depending on the medium, interestingly enough, like the ocean also experiences light attenuation, but it's at a different rate. And like, ironically, the green spectrum actually penetrates further than the red or any other color for that matter. The green seems to be the last one to, as you go deeper and deeper into the ocean, some of the light rays become completely obstructed, right, by the water, or diffused by the water would be a better word. And then you'll notice that everything gets a green hue as you go deeper, because the green spectrum, for whatever reason, and I don't entirely understand why yet, penetrates further than any other color. It's opposite in the Atmos though. The green is obstructed first before the red, but not in the ocean. So the medium does play a role.
All right, let's do this, people. Then oh wow, it's too big. Can't even see the friggin' peaks. All right, this first image in the chat is San Jacinto on a globe with standard refraction. Looks very much like Jay Tolan's photo. And that's no refraction on a flat Earth. Which one does the photo match?
Let me look.
Anyone clever enough to do a ghost overlay of that roof?
Possibly.
I'm not suggesting you. I'm just anyone.
No, I've got it here, so I'll do it. Let's open a little PowerPoint, shall we?
Mm-hmm.
Oops.
Roohif, are you able to determine the degree of tilt away each mountain is?
No.
Not at that distance.
No, I would say not at really any distance.
Mm.
Okay,
How are you supposed to do that?
And a mountain's not vertical like a building.
Well, this is 123 miles, so it's tilted away less than 2 degrees. Good luck.
Wow.
Oh, this is the one from Point Doom. Not quite the same observer, but close enough. I'm on interwebs. There we go.
Anyone see the poll that Plastic put in?
Yes.
You got two choices. Your vote.
Transparency. When did I say that, jackass?
Yeah. I told you to do it all day, every day. His grammar and his vocabulary and his text are just as bad as his vocal comment.
Right, share screen. I'm using the wrong photo though. Yeah, I've got to use a proper photo. I'll do it from Point Doom. Give me a few minutes.
What's the contention with this photo, Riff?
That infrared allegedly doesn't refract.
Hmm.
I'm using the 123 mile photo rather than the one taken from Malibu. I'm going to move the observer.
What y'all talking about?
Infrared and how it proves the Earth's a globe. The end.
Yeah, I pretty much agree with that.
Nice. Oh, excuse me.
What am I looking at? I
Well,
can't see, dude. It's too small for me. I'm on my phone.
You could disagree, and then we could have an argument about it.
Good.
Well, I was trying to talk about it earlier. I got freaking banned.
Oh,
where'd you
That's
get banned?
good.
I don't want. I just want to listen because maybe I'll get banned again.
No.
What you mean banned, dude? What are you talking about? You're back if you got banned.
No, I had to make a new account. I'm Tank from the Matrix.
What?
Yeah, I recognize your voice.
No, I know who you are, bro. I know who you are. Now, it couldn't have been because of that. You must have been disruptive.
No way.
I was
Yeah, you might.
I was just trying to make that a point about the infrared on the James Webb Telescope and the other telescope technologies, but I guess it was off topic or something.
No, I wondered where you went, Tank.
Okay. Well, you shouldn't have got banned for that.
Tank, you wouldn't have got banned for that, hon. I don't know why. If you got banned
probably
for
got
that,
timed
that's a
out,
mistake.
or you can get timed out for a day or 4 days, depending. But banned, dude, for
Yeah,
something like that, I doubt it.
Yeah, it has to be pretty severe to get timed out or banned.
Well, I don't want to distract anymore. I'll keep talking.
All right, sorry. It's all good. But yeah, I can't see what's going on. So what are you showing us, Roohif?
So I've got the right photo and the right render.
So you got do you have a model and then you have the original infrared? Is that what's going on? And then you have the predicted measurements comparison.
It's just overlaying a photo.
Right, but the model is based off of what?
Oh, optical standard refraction.
So you have the model of the Earth, right? The expected radius, and then you included standard refraction.
Yep.
Okay. And
Terry,
we're comparing it with the
give an
infrared.
idea of how good a match it is.
Yeah, you go. That's pretty good. That's 123 mile away at a viewer height of
whatever point Doom is. Dumay, actually. He's about
Looking at right now. I just want to see the compare.
64 meters.
we have to work in miles because I have to work that out in
Because we're
kilometers.
Americans.
Yeah, I know. I can't help it if you're backward.
Do you want to see what it would
I
look
mean,
like?
it looks identical, dude. I'm not, but again, I don't know, dude.
What do you mean you don't know? It looks identical because I've rendered it, I've modeled it on an Earth with standard refraction, on a globe with standard refraction. That's
I know, but I don't know. I don't know, dude. I don't know what you did, bro.
I just modeled it on a globe with standard refraction. That's it.
Something interesting is they're using some really highly optimized infrared sensors detectors compared to even just like 5-10 years before James Webb. So some of the new telescopes are pushing these technologies to get better. So like,
How does that relate to this Earth-based image?
Can you guys see the James Webb Telescope? Like you can see the ISS, like on its magical pink carpet.
I don't think so. No. James Webb's a long way away, isn't it?
Yeah, it's a few kilometers away.
Roohif, did you know James Webb resigned before the moon landings?
Wow, cool.
that's intriguing.
It's cool. That's all Roohif has to say.
Yeah, so James
That's
Webb
why
is at
you're
the
laughing,
moment.
Roohif. You know it's funny. His party was like,
That they designed a telescope before the moon landings. I designed a orbiting telescope. Cool.
I completely disagree with the dating with a lot of the information they get. So that's what puts me on the fence a lot. God only knows what part of this stuff is classified, where it falls off, where it turns into bullshit.
Now let's copy this slide. Duplicate. Delete that one. Delete that one. Now let's render it on a flat Earth. This will be fun.
Uh-oh.
Ooh, the panorama.
Any predictions, anyone?
Uh-oh.
So it's 120 miles, right?
Yep. Oops. That one.
And so it's 120 miles from the observer to what? To the face of that mountain?
To the peak, yep.
To the peak. And so you guys already figured out the observer height, the elevation of the observer, and the elevation of the mountain and all of that?
Yep. We're almost there.
Because 123 miles, that's a lot, man.
Yeah.
At 8 inches per mile squared.
Yeah, and you can see on screen now what that looks like.
Huh?
That's what it should look like on a flat Earth.
On a flat Earth.
But it looks like that.
Let's see where he's going.
It's hard for me to see what's going on. All right. Let's see.
It was the same freaking mountain.
Right, but where's the horizon and the foreground? See the ocean? That's the ocean in the front. Uh-oh. Oh.
Oh, the horizon is beyond the mountain. Right? The mountain's only an obstruction.
No, the ocean horizon.
Right. But
The ocean.
Yeah.
Yeah. So that's flat Earth. Let's go back to the globy one.
What you think you would see on a flat Earth? Is that what you're saying? What you think you'd see on a flat Earth? What you believe you should see on a flat Earth?
Yes.
Did he account for refraction?
He's accounting for standard refraction for 120 miles, which over 100 and some odd damn miles is a ridiculous amount of refraction to try to do a standard refraction. That's a little bit ridiculous. You know, over 100 and some odd miles, that refraction is going to dramatically change, honey.
And yet, it's a near perfect match when I include standard refraction. Look at that.
So the Earth is flat?
No, this is the globe one.
I know, I'm just messing with you.
How perfect is that, Stacey?
As perfect as you want it to be, Roohif, with your standard refraction and your model and your little calculations that you guys do for 100 and some odd miles of drop, babe. Come on now.
Yeah.
But his model is our model.
Isn't it crazy? What are the chances it would match exactly if we just assume a standard atmosphere? That's crazy, isn't it?
No.
Crazy.
You guys did it on purpose.
No, just you can give me any location in the world, and I will give you a render of what it should look like.
Why can't we have standard refraction on a horizontal ground?
Well, you can. Of course you can, but it would make it worse for you, unfortunately.
What I see on this right now is what I see.
I think it's Chuck Missler has some of the best data I've ever heard on debunking some of the flat Earth stuff.
Chuck Missler, dude?
Yeah.
Oh my god.
Heard the
No,
name.
you're talking about Michael. I think you're talking about Michael Heiser. Maybe Chuck Missler. I don't know.
No, you're fucking right. You're fucking psychic or
I
something.
think you're talking about Michael Heiser. Well, I'm familiar with both. Michael Heiser is the one that really pushed against flat.
No, it's not Michael Heiser. But
No?
there's another old preacher that I miss. Yeah.
Yeah, he's a mathematician. You're
Yeah.
Matrix.
Sorry,
You were
sorry, go
referring to the math. Yeah.
Who is it? I'm just wondering. You know what you're talking about?
I can't remember his name. He's like he does a lot of like street what would you call it? Evangelism?
Is he Canadian?
Shit, he might be.
The black dude with the dreads? Or he's actually mulatto.
Give me a minute and I'll find it in my YouTube history.
Is mulatto like a
David Lynn?
A bad no word over there?
I don't know. People get offended over everything nowadays. I don't know.
Yeah, I like David Lynn. Great story.
But he doesn't break it down from a scientific perspective, right? He just debunks it from a biblical perspective, so I guess it's different. But for me, a big part of it is biblical, so
Okay, I'm sitting here watching your video and I'm really trying to understand you right now. Because 120 miles, that's going to be a big drop. What am I seeing here? Can you go over this again, Roohif? Because it looks like I'm seeing exactly what I should see.
On a globe, yes. This is
123 miles.
Can you explain to me what you're saying? For 120 miles, you're going to see a massive, more than that. You're going to see a drop. I wouldn't see what I'm seeing right now.
There should be no mountain on the globe.
Well, no, you'll still see the part of that mountain, but you will not see what I'm seeing on the globe.
Okay, this is the prediction of what you should see on a globe with standard refraction. And
I'm supposed to see all of it.
I see what he's doing now. I understand. So now you're saying the standard refraction should make the mountain appear, right? Where normally without standard refraction it would be completely obscured, right?
No, not saying that at all.
It's a mirage on the globe right now.
Wait. Go ahead, Rick.
Yeah, not saying that it's hidden without refraction and is appearing due to refraction. It's appearing because it's in infrared. That's probably the main reason. How much does refraction lift it, actually?
Hold on. But what I'm saying is that usually you guys, when things are completely resolvable or appear above the predicted curvature, you guys invoke refraction, right?
There's always refraction. Always. You should never not use refraction.
You're saying that refraction's the reason why things appear when they should be completely obscured, right?
When you
Even though
say
you
they
haven't
should
really
be
proven it.
obscured, when you say they should be obscured, you're assuming there's no atmosphere.
I'm not
Incorrect.
assuming anything. I'm just saying that
Yes, you are. You said should.
You haven't verified that every time something appears above the horizon, where it should be, according to the predicted curvature, should be obscured, it's because of refraction. But that doesn't make any sense.
As soon as you say the word should, you are making a prediction, and there are assumptions or something behind that prediction. What are your assumptions behind your prediction?
Well, no, it's not an assumption, right? It's not an assumption. From what we know, right? Light bends towards a denser medium, causes things to disappear, right? That's why we get bottom up obstruction. That's why things.
What? Start again. Light bends towards the denser medium, makes things disappear. How's that work?
No.
So, light, when it hits an object and refracts off or reflects off an object, that light is going to bend towards the denser medium and never get to reach your eye, right? Because it hits the earth. The light rays hit the earth. They get obstructed.
Hang on. I'm cracking out the crayons in paint.
Don't Roohif do this.
I got it.
Now, this has already been demonstrated that there's a downward bias with refraction. You have you have the crosshairs on a theodolite. When you balance out your total station or whatever device you're using, transit, whatever, it's well known for hundreds of years now that you have basically 4 different types of refraction. So when you have the crosshair set up and balanced, and you line it up with the horizon, above the crosshair you have looming refraction and stooping refraction. And then below the crosshair you have sinking refraction and not stooping, excuse me. Below the horizon you have sinking refraction and stooping refraction. Above the horizon you have looming and towering refraction. And then you can include you got your superior mirage that's also above the crosshair or above the horizon. You got your inferior mirage that's below the crosshair or the horizon. Now, almost every single time when you look through the theodolite and you level it, the optical horizon, right, the apparent horizon, because you guys call it, you think it's geometric, but the apparent horizon's almost always 99% of the time it's below the horizontal of the crosshair. Why? Because of sinking refraction, right? Because of because of the lenses of the theodolite cause the horizon to a dip. There's a horizontal dip below eye level. This is well known and established for almost 300 years. Now,
Anyway.
why is there a bias towards the bottom half of our field of view versus the top half? It's because light bends towards the denser medium. Go ahead.
Right, let's get back to where you said the ray wouldn't reach your eye. I busted out the crayons. All right, so the sun's up here, whatever. Oops, shit. Ah, crap. Hold on.
Please don't be perverted with your drawings, please.
It's
I feel like you're repeating on the house.
It's a gay little house. All right, so got the sun up here. Cool. And it's shining down onto our gay little house. All right. And what you're saying is that this light ray that bounces off the house and heads towards you is going to hit the ground because it bends towards the denser medium, right?
That is the idea.
Excellent. Okay. What happens to the ray that bounces off at this angle? What happens to that one?
It's like it scatters, but that's why.
Oh, what?
That's why the top of the object, right, is still visible compared to the bottom half. That's why you get. That's why you get bottom up obstruction. That's why the obstruction begins at the bottom first, not
We're
the
hitting
top.
the same spot on the roof. It's one ray's bouncing off this way, horizontally. Another ray's bouncing off slightly upwards. Where's that ray going to go?
It's well, if you consider both Snell's law and Fermat's principle, depending on the angle of the light, whether it's 25 degrees, 45 degrees, 90 degrees, if it's going to bend at different rates. I can't exactly predict. It depends on the gradient densities. It's kind of complex, bro. But I would expect the light to bend away, right, in a way that it will never reach your eye. Either way, it's called light diffusion, light scattering, attenuation, all of that.
All right. So this one bounced off horizontally, and you're right, it bends down, hits the floor before it reaches my eye. This ray bounces off at a different angle, still bends down, but goes way over the top of my head. What about this ray? What about that one?
Yeah, so it's like I said, it's the light has a natural bias to bend downwards towards a denser medium. Now, this image right here is a very crude representation of what's going on in reality. It's not to scale at all. That house was going to be way farther away, and the way that the light hits that house when you're talking about 20 miles out in the horizon. Yes, the top of the house is going to be the last part to be obstructed, right? Because it's higher. Now, the bottom of the house is going to be completely obstructed. You might only see the tippity top of the roof. And depending on the atmospheric conditions, the greater the refraction, you're not going to see the house at all. That's just a fact. You can take that to the bank. Refraction causes things to be completely obscured. The less refraction, the greater visibility. That's why the Weather Channel, they talk about, today's you have, 3-mile visibility. Why? Because there's less refraction. The more refraction, the less visibility. You disagree with that?
Hang on. Here we have a mountain.
No. Do you disagree with that?
His understanding of refraction is rubbish. That's what I'll say.
No, his last
not rubbish.
statement, at least. Do you understand what he meant by that?
Say it again briefly.
Let me ask you. With less refraction, it increases visibility. With more refraction, there's less visibility.
When you say visibility, I'm wondering whether you mean scattering or bottom-up obstruction.
All of it combined. With less refraction, you have less scattering, you have less diffusion, you have less refraction, all of that. Because when you have gradient densities, when you have atmospheric particulates and dust and pollen and this and that, it's going to cause things to be less visible, bro. It's pretty common sense.
Less resolvable because of scattering? Or more obstructed bottom up? They're different things.
The less refraction, bro, right? The less evaporation. There's going to be greater visibility.
Yes. Also, Roohif, in your image, can you cut that mountain out and tilt it 1 degree away, please?
Okay.
Thank you. Or maybe 2 degrees.
Okay.
What do you mean by the bottom up?
Who, me?
Oops. There you go. Just pretend that's 2 degrees.
No, Rohifnol. What do you mean by the bottom up scattering?
Well, he's saying with the less refraction, causes both scattering or less scattering and less bottom-up obstruction. They're different effects for different reasons.
Now, I'll give you this. I'll give you this. Right? There's rare instances where refraction can cause something known as a superior mirage or fata morgana, or looming, right? Where things appear way higher than they should. Boats float. You can see things but that's very rare. That's very, very rare, and that's the exception, right?
Yeah, but
that's
it's not
exception.
Refraction either.
Hold
Yeah.
on. I don't know. It's considered reflection. Regardless, you can catch me in a technicality. You know what I'm saying, bro. So now to dwell on the exception when we know that there's a downward bias and 90% of the time things dip below the horizon because of refraction, to say that refraction is causing things to appear above the horizon is foolish, bro.
Okay, bro. Anyway, where were we? This was the mountain. So we've got the sun hitting Sun
What
hitting the
refraction are we
base
dealing
of
with?
the
We're here,
mountain.
Roohif, by the way, so we know. Are we doing terrestrial refraction? Is that what we're focusing on here?
Yes, we're on the Earth. We're not looking at
Yeah.
things in space.
Okay.
Well, I
Now,
think
you just said earlier with what? Less refraction, right? Less refraction. I should have less obstruction, though, correct?
No, more refraction if you have a steeper gradient. So when he says less refraction, that means to me a gentle gradient. So less refraction means you have more obstruction bottom up.
Are you tripping?
No, I'm
He's
not.
coping hard right now. He's coping hard, dude.
Well, listen. If there's a clear day, let's just talk about a nice clear day, hardly any refraction out there. You're gonna tell me I'm gonna have
can't
more
say-
obstruction?
You can't equate a clear day with less refraction. Those two things are
I
not
just
related.
said both. I'm giving you both. No, Roohip, I'm giving you both. Don't do
Okay,
it to
a
me.
clear
You know
day.
what you're doing here.
A clear day with less refraction, yeah, you'll have more bottom up obstruction.
Hardly any refraction. Hardly any.
Yeah, the less refraction you have, the more bottom up
Mhm.
obstruction you'll have.
Wow. This is why refraction needs to be done again. Go ahead.
What would you expect? What would you expect in a vacuum? Theoretically, if the Earth had no atmosphere, what would you expect then?
Yeah, we'd see the geometric horizon all the time. That would be the horizon.
I just think you're messing with.
Hang on, I've got a GeoGebra that I think is probably going to be easier.
Can I ask Lion a question real fast?
Yeah, go ahead.
Chuck Missler, I looked it up. He originally postulated that the Bible proves like a round Earth, but now he's got documents on Pinonia House, his website, that are very extensive that talk about the holographic universe and how it supports the flat Earth. Which is
Yeah,
I
he's
just
a
finished. Yeah,
I haven't kept up with him. He's still alive, Chuck Missler?
I'm not sure actually. I thought he passed away.
They all.
Great
I think
mathematician.
Michael Heiser passed. I think they all passed away. Rob Skiba passed. They all passed away, dude. It's nuts, dude. Chuck Missler, Michael Heiser, Rob Skiba, dead.
Yeah, like 2018 was when I think it was like 2015 or 18 or 20. So it was recent that Missler died.
Yeah, Chuck, he was taking on evolution and trying to debunk it using math.
Yeah, his content's
There we go.
going
All right,
low-key
ready?
viral right now.
Are we ready?
Yeah, I'm ready. I'm watching. I'm looking. Don't worry. I'm looking.
Cool. So I'll make that really tight. All right. So I've got two sliders. One is the observer height in meters, and this other one, the light radius. Right. So if the light radius is small, so small being 8,000 here, this is the radius of curvature of the light. Right. How much the light curves. A smaller radius means that it's curving a lot, and a big radius means it's going pretty straight. Right, so that yellow line, right? Does that make sense? Big radius, relatively straight. Little radius, curving a lot. Cool?
Mm-hmm. Yeah, I'm looking. It's a little small, but I can see it.
Okay, I'll try and zoom in. So this is, that's probably Kanigu actually, that one. Let's move in. Let's just do the horizon first.
Why is it not tilting away?
Did I make it tilt? I don't know if I did. Maybe I did actually. I think I did. Look, yeah, I think I did.
Okay, thank you.
Tilting, yeah, it's tilting away like 2 degrees, which is nothing, right? So
This is why you guys try to win all the time, though. You know, when we see things, you're just like, refraction! Too much refraction!
you can
It's
hold
like
us
you guys have
to-
used it against us. You guys have claimed refraction, took it, and try to own it for your, like, winning battle game.
Right, this light radius here, this is approximately standard refraction. It's about 44,000 Ks.
Even though you guys have only studied it for like 200 meters, right? But you know that far?
Right.
Interesting.
No, I think you brought that up before, and I asked you to send me what.
Yeah, and it's also been talked about. Have you looked into it yourself? Because I've already talked to professors. Roohif, have you know anything about refraction, how long it's been studied, and how far? In a lab or anywhere, any source? How far?
People,
how far?
They do it over hundreds of kilometers when they do trigonometric hiding.
Okay, show me a test where they're doing over 100 kilometers and there's proof of refraction in this way. Then show me one test.
Okay, it's in the
Wait Ready, please?
American arc of the parallel. I haven't got it to hand, but it's in the arc of the parallel. They do reciprocal angles to get heights of mountains. And they have to,
I'm not asking for you to do a measure. I'm asking studying refraction. And also in a lab source, figuring it out because they're quantifying it after 200 meters. Do you understand that?
Yes, I have never seen a limit of 200 meters to refraction. So anyway.
Now, there's not a limit. It's only been studied at 200, and after 200, it's quantified for your little d in mathematics.
All right. Anyway, so this is the observers at 500 meters.
Exactly. Avoid it.
Well, I'm sharing so that I can explain this. All right.
I understand.
Refraction lets you see further. So this is less refraction. This is standard refraction. And you'll see that the red dotted line hits the globe Earth at G. That's the geometric horizon. But the yellow line is the actual curved path of light. And it hits a little bit further. So this is where the horizon is. All right. So here it's about 80 Ks and here is about 86 Ks. All right. If I turn up refraction, make it stronger, so the light bends more, guess what happens to the refracted horizon? Gets further and further away. All right, so we can see more around the bend with stronger refraction. And so this is Canigou. So with Canigou, I think, Canigou is meant to be, hang on, they're 300 meters at Canigou, aren't they? So I'll set the observer about 310 or 320, I think. One of those. That's that. All right. So it's close to no refraction. With the red line is no refraction, straight line of sight, misses the top of Canigou. But if you have standard refraction, about 44,000, you see the very tippy tops of it. Cool. That's what we see.
I don't know, dude. That seems like there's too much fuckery.
Dude, this is literally a 2-scale representation of the Canigou observation.
To me it feels mostly theoretical. It hasn't really been substantiated. But I get it works out on paper, but I'm not entirely sure that's what's going on in reality. Because you're asserting that refraction makes things appear. I don't know that to be the fact yet. I don't.
Well, look at the path of light. Light's this way. The light's curving from this part of the mountain, curves into the observer.
Roohif, do you remember the index number for refraction that was used for that time? And do you remember the temperature?
No. Don't make me bring up the graphs. Once you get above the surface, the typical gradient, the refractive index changes from whatever the height is per vertical kilometer, changes by 0.000023 ish.
How do you know it changes by that and only that standard?
Because I
over
have the
that
data.
mile. Wait. But you actually have the data that they went out there and they asked you, or is that just figured out that they say that's what it should be that day? Do you actually know at every mile, 2 miles, 3 miles, it's actually changing and you're using the correct refraction?
No.
Do you know?
Every single weather station, once you get above the surface, clusters around that value. That's why we use that value.
I understand. You guys use a value. There's an actual standard value. But in reality, is that happening in your atmosphere for a fact? Do you know that after every single mile?
Yeah. All the data
you know
says
that
so,
for a fact.
yes.
That's the biggest lie I've ever heard from anyone on here at Roohif, because I've heard Globers even say that there is probably a change, and they cannot stay with standard refraction. That that they agree that it needs to be revisited because over 100 miles, especially using standard refraction, you would not know. It's going to change. You're using this because, it's going to change this much in a mile. It's going to change this much in a mile. But you don't even know what's going on out there. You're just using the same fucking refraction every day. Oh, it's about this out there. This is going on out there.
So, why is it that when you look through a theodolite, that the horizons always
Stacey
appears
asked for the
below eye
graphs.
level?
Stacey asked for the graphs. Hold on.
Oh, goodness gracious.
Here we go. What's this one?
You're
is this one
Roohif,
is
you focus on the
Boise,
wrong things of discussion.
Boise, Idaho. This one is Denver. This one is Santa Teresa, New Mexico. This one is Key West in Florida. What else have we got? This one is Lamont in.
It doesn't matter though, because that's all in reference to the predicted curvature of the Earth already.
No,
So
it's
like,
not. No, it's not. You keep
how do
saying
how do we
wrong
know
things.
that? How do we know
Because
that?
these are vertical measurements. They just send a balloon up. Nothing to do with the curvature of the Earth.
Vertical measurements of refraction.
Yes.
How do they measure that?
They measure the
They just
temperature,
a
pressure,
laser or
humidity, and
something?
the altitude. No. Temperature, pressure, humidity, and altitude.
Yeah, but how do they measure it though? The refractive index. They just get the
Yeah, those
those.
are inputs. Those are inputs into an empirically derived formula to give you the refractive index.
So
This is a formula, hon.
they gather the temperature, humidity, the pressure, all of that, and they put it into what, an AI, or some
No, into a
algorithm, and
formula.
it poops out some formula for standard refraction. Like, I don't understand.
Into a formula that was derived from laboratory experiments.
I've only so many meters. This is what I keep saying. And then they're quantifying everything after that because the atmosphere does this over 100 and some odd miles. They
Look at
say
the
this
shape of all
happens
the graphs.
every single time I use the same refraction on every single day, depending on what the temperature is in that certain area. Then every single mile after that, they keep doing it, quantifying. This is absolute bullshit. This is my refraction is crap.
Do all the graphs have a similar shape?
Oh, for fuck's sake. Roohif, I'm not doing it with you about the grass.
Well, this is the data. This is the data.
So,
You know what you're doing,
Roohif, what's the standard refraction index at room temperature? Do you know the
standard
approximate?
gradient? The standard gradient, the refractive index changes by 0.4 zeros, about 2.3. 4 zeros, 2.3 per kilometer.
So why is it that
kilometer.
when you guys do theodolite, when you guys do theodolite measurements, that it's recommended to do it at at least above the what's it called, the marine layer?
Yep. Get above the surface. Yes.
How much higher above the surface would you recommend?
My data says about 100 meters is pretty safe.
100 meters is pretty safe, but the higher you go, it becomes better, right? Like, theoretically, if you're in a mountaintop, like let's say you're 11,000 feet up in Afghanistan.
Yep.
Why is it better up there?
That's the gradient is much more stable when you're well away from the surface.
Yeah, there's less refraction, right?
No, not less refraction. Right?
Oh,
it's more stable.
Can you at least admit one thing? Because I asked you about a lab. I asked you about quantification. Now, can we at least go to standard refraction, like I just asked you earlier? You told Lion they go from a lab, right? And then everything after that is going to be quantified. Isn't that correct?
Is it quantified?
Yeah, for your math. You did a test in a lab for how many meters?
No.
This is what refraction's using. How many meters?
Yeah, probably 30 centimeters. That tiny little piece of equipment that measures.
So we're talking about the refraction that y'all keep using every day. How many meters? Then it's quantified, please.
As in, how over what distance was the refractive index determined in the lab?
Correct. This is what you guys keep
30
using every day when you claim refraction. So I
centimeters.
want to know when you're using it and you came up with it, how many meters, and then quantified, please.
Yeah, probably 30 centimeters. They're tiny little things. They've got a vacuum in one path.
There.
and
So
the
everything that you
sample
guys keep using every day, about 100 fucking miles, is from how many damn meters, honey? In a lab.
in a lab to determine the refractive index of
You're
air.
welcome, everybody. Have a nice day. Don't need to speak to Professor anymore, do you, Roohif?
To determine the refractive index of air with those characteristics. That's all they did. So it's so that I know that if the temperature is 20 and the humidity is 50% and the pressure is this, I know what the refractive index is. And then I apply that to these measurements of the atmosphere. which tell me
I'm really glad that we got on the same page. We don't need to go ask a professor now. I've already done my work. I've already done it on the streets. And I've already talked to them. Your standard refraction that you kept denying, would not admit, is from a damn lab that you quantify. And then you want to go 37 meters to 100 and some odd damn miles. Roohif, this is where you guys go wrong.
Jesus.
Now I'm going to go outside and have a
This is where you're
cigarette.
not
And thank
understanding.
you for admitting finally that you know about the lab and you know how many meters that you guys are quantifying. Have a nice day with your dumbass refraction, Roohif.
Okay. Thank you, Stacey. I love
Hold
you
on.
too.
I think I understand where the misunderstanding is.
Have a go.
What's understood in a lab is the refractive index. Standard refraction is done in the field.
Incorrect.
Have I got that wrong?
Correct. So,
yeah, okay.
have I given you this lecture, manufactured item? I may have. So basically, there's a. I'll stick the paper in the chat. One sec. I'll stick it in the chat after I stick it in your mom. All right, paper's in the chat, and that's the paper that an Aussie guy did actually, and he took a whole bunch of empirical lab experiments, and all those experiments came up with formulas for the refractive index of air under certain conditions, and he made them super accurate. So the refractive index is usually given to about 6 decimal places. This guy got it, gave the accuracy to about 8 decimal places, which is pretty cool. Anyway, so that's the basis. So this paper basically gives you a formula. If you plug in the wavelength, temperature, pressure, humidity, CO2, blah, 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 you get a refractive index, right? And those graphs that I kept showing are from weather balloon data, where they don't calculate the refractive index. They just get the temperature, pressure, humidity, altitude, blah, 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 right? So I take that data, and for each sample that the balloon takes, it's like, oh, here's the sample at 100 meters. I calculate the refractive index at that 100-meter height. Then the next sample might be at 200 meters, and I calculate the refractive index there. So I've got a change in refractive index over that 100 meters, and I just normalize that to a kilometer and stick a dot on the graph. So that's what those graphs are. Does that make sense?
All right. What about when things are obstructed way sooner than they're supposed to be? What do you call that?
Like such as?
Yeah, like the bridge near Rakia's crib.
The bridge or his
I forget that bridge's name.
trolling boat. The trawler?
You go the one that you can take a photo from the left and it looks like it's curving left. Yes. And if you take a photo from the right, it looks like it's curving right, but really the bridge is curving left or right. And at times it's like the earth is freaking blocking it way sooner than predicted.
I've seen a few inferior mirages on Pontchartrain, but do you have one without an inferior mirage?
Or any observation where things are obscured sooner than predicted, than the radius of the Earth predicts.
Yeah, the only
What's
one I
causing
can think
that?
of with Rakia's got a fishing trawler that he claims was, I think, 5-6 miles away. Rakia has apparently, not while I was there, but apparently acknowledged that there was quite the swell on that day. So, yeah, and that the boat was bobbing up and down. That's the only one I can think of. I have another one. Please present it. Oh, it's time. 8:50. Holy shit. I haven't fed dogs yet. I'm going to do that in 10 minutes. Did you follow the explanation? MFT. Motherfucking totem.
Yeah, I got it.
Yeah, I've been giving this lecture to Flurfs for probably 6-7 years, I think.
Yeah, I've been trying to explain refraction and how light curves for a while. I don't know if it's. I don't know. Ultimately, it's as far as I can tell, it's one of two things. It's either special pleating, where we understand how light works, we understand refractive indexes, but somehow, for some reason, they just break down at distance. Or I don't know if it's an appeal to possibility exactly, but whatever it is, there's something in the atmosphere doing something that transforms all of these globe observations to
There's some special particulate matter that just makes Snell's law go in reverse or something. Yeah, I've heard that before as well.
Yeah.
Cracking
But the main
stuff,
thing,
people.
what gets me, when you talk about celestial navigation and the angles to Polaris, the amount of refraction you would need for that is something on the order of 25 to 30 degrees.
Yeah.
But something like 6 arc seconds at the Black Swan is apparently too much refraction. It's like a panacea.
Oh, it's a couple of minutes, isn't it, for Black Swan? I think.
I think I don't know. I calculated to 9 arc seconds. I think Scott Mackey said 4.
Hang on. Someone said before the horizon being below eye level due to refraction. That's rubbish. Due to the Earth being a globe. Check the chat.
Well, I have quotes from the Royal Astronomical Society in the 1800s testing the horizon at sea level. We're talking about 6 inches above the water, at 20 feet, at 50 feet, at 100 feet, at 150 feet. Many observations were done, and even 2 miles up in a weather balloon, or not a weather balloon, a hot air balloon. In the basket, they set up an experiment. At every single instance, they had a theodolite with glass, and then they had basically a steel tube, a steel pipe that was closed at one end with a small aperture right in the center, and then on the other end it was open with a crosshair. And they compared the observations through the theodolite and then through the steel pipe, and they noticed that at every instance, including at sea level, the horizon dipped below eye level through the theodolite, through the glass of the theodolite. Now they figured that because of the glass of the theodolite, there was some type of refraction occurring. They called it collimation. That made the horizon always appear below the horizontal line on the crosshair. Now in modern times, they know about this and they correct for that. Even in the manufacturing of the theodolite, they try to correct for that. And there's also calculations.
Horseshit.
It's not, dude. I can do that. Dude, I have books that talk about precision manufacturing of optics, including telescopes, theodolites, and cameras, all of that. And this is something that is well known in precision optics that they have to account for. It's called collimation, because light bends downwards. What?
Do you want to hear why it's horseshit?
Why is it?
Because you can flip a theodolite. You turn the theodolite upside down to make a second measurement, and the horizon's still below horizontal.
It doesn't matter the orientation of the theodolite. It has nothing to do with the orientation of the theodolite.
So it's nothing to do with the theodolite or the optics.
No, the light always bends downward. It doesn't matter if you hold the theodolite backwards. It has nothing to do with it.
Yeah, you just said they made things for the
way.
optics.
Yeah, it doesn't matter the thickness of the lens. Whether it's not, is the thickness going to change when you turn it upside down?
No, you're looking through the center of a circular lens.
Right. So why would it matter if you flipped it upside down?
It doesn't. You're the one that claiming they had to do corrections for the lenses or some shit.
No, the thickness of the lens causes the light to bend down, dude. Literally, it doesn't matter how you orientate the lens.
The crosshairs are in the center of basically a spherical lens. Right? There's no distortion through the center. That's why the crosshairs are in the center.
No, there's still a horizontal dip, dude.
I agree.
Now,
there
if
is
you
one in
want me, I'll
reality.
pull up. Dude, they're Globers. These are Globers that are observing this. This is well documented.
The horizon is below horizontal, yes. Nothing to do with the optics.
No, it is the optics. How do they know? Because they use the steel pipe with no lenses just a regular steel pipe with an aperture on one side and a cross on the other, and they did the same exact measurements. They had both it was perfectly leveled, just like the theodolite was perfectly leveled. Yet every single time they looked through the theodolite at every elevation, the horizon was always below eye level.
Yes,
below the
nothing to do with the theodolite. Right.
Now, when they look through the steel scope with no lens, the horizon was always at eye level, always with the horizontal line on the crosshair. Even at 2 miles up in a hot air balloon.
How do you level a theodolite in a fucking air balloon?
Listen, they did it. It's documented.
I would love to see how.
I got the names of the scientists. It's the Royal Astronomical Society from the 1800s. Yep. Now, with that being said, even in geodesic measurements, they account for this. This is well known, bro. And they correct for this in the calculations, just like you have standard refraction. They correct for it.
Refraction, yes.
They're correct for the horizontal dip. That's why for example, when it comes, you brought up
surveyors. Surveyors don't.
Hold on, dude.
Point at the horizon, dude. Surveyors never point at the horizon.
I'm not talking about that.
I've got to interrupt when you just talk absolute.
I'm not talking about that. I'm talking about collimation. Look up collimation, bro. Yes. So to correct for collimation, what they do is they have the stations point at each other, and they act like that's gonna cancel it out. That cancels out any collimation error. Go look at it. If you don't,
do a two-peg test.
I know what I'm talking about, dude.
No, you don't. You clearly don't. To fix the collimation of a theodolite or an auto level, you do a two-peg test. Would you like to see a video of me doing a two-peg test?
Oh, so now you know what I'm talking about all of a sudden.
Yeah, because I know that you're full of shit.
Right. So 2 minutes ago, what are you talking about? There's no collimation. Now there's collimation. That you have to correct for.
Is an error that you can adjust out of an instrument.
No shit. That's what I'm telling you, dude. And you're ignoring it. You're acting like that. What are you talking about?
So you're talking about people just using an uncalibrated instrument. Who gives a shit?
Exactly. So you have to calibrate, as in, i.e., you have to correct for an error that's known as collimation that's caused by the lens of the theodolite.
It's caused by your theodolite being out of collimation, I guess, out of alignment. There's no downward bias.
So they have to correct for that. They have to realign the horizon.
Calibrate, not the horizon. Not the horizon.
No, I know. But you can notice this collimation error. You can notice it by using the horizon as a reference.
No.
Now, granted, they don't use the horizon when doing reciprocal zenith angles. I understand that. That's not the point here. The point is you can notice this collimation error when you level out your instrument and then you reference the horizon with another instrument that doesn't have any lenses. You can see this error manifest.
Surveyors never reference the horizon. That's just rubbish.
I didn't say. I know that. I just told you that. I granted you that. I'm not talking about that. I'm saying in order to notice this error, though, you can use the horizon as a reference to notice this error.
You can't do that.
You don't use the horizon for spherical axis or reciprocal zenith angle.
How do you compare it to a horizon? Like, what if it's a strong refraction day? Then you've just adjusted out a collimation error that isn't there. It's retarded.
Now, here I can't pull it up right now, but I got manuals. I got a manual on precision optics and the manufacturing of precision optics. It talks all about this stuff, dude.
Right.
And when you talk about lenses and like barrel distortion and chromatic aberration and all this and that, collimation is just one of many things that lenses cause light to distort, right? You agree with that?
If you're looking through the center
of a
circular lens, then no, it's not going to do that. What's your username now? Lion. All right.
Can you post the original 1800 thing?
Yeah, hold on. Give me a second.
I remember reading that.
Right. There's a video of me calibrating an auto level using a two-peg test. All right, I got to feed doggies. It's 9:00. See you soon.
Yeah, I remember you posting that 1800s thing, and I remember reading it and it not saying what you're saying it says. I mean, I don't remember off the top of my head, but I remember there being issues with that.
And they even said that it looked concave, dude. The horizon, at some point, the higher you go, it looks like it's curving up. But it's not actually curving up. It's all due to, distortion. Like the edges looked like they were curving up. The point is that for whatever reason, though, there tends to be a downward bias when it comes to the axis of the theodolite, the crosshairs. Almost always, you'll notice things below horizon. And you guys say, well, that's because of the curvature of the Earth.
Yeah, the curving up wouldn't affect what the crosshairs are in reference to. The light's doing whatever it's doing before it ever gets to the theodolite. Like, it's not going to bend the light out in the distance.
No, I agree. So it takes extreme refraction to cause things to appear below the horizon, right? You guys act like extreme refraction causes things to manifest or appear above the horizon. That's not the case, dude. The more refraction there is, it acts as if the globe is way smaller, dude. As if the curvature is way higher than the expected 8 miles per meter squared. I mean, per mile squared. No, that's what happens. The more refraction, the more atmospheric density, the more water vapor, evaporation, heat, it causes things to literally completely be obscured. You guys act like, no, that causes things to pop up.
Yeah, that's just not how it is. Something. So what Roohif was trying to illustrate with that the house and the little guy. You understand that when light bends down, our eyes presume that light is going straight always. So if we get light bending down to our eyes, it projects the location of that object upwards, right? Like light bending down lifts the apparent image.
Yeah, I know you guys assert that. And that on paper it might sound good, and you might have standard refraction.
Good.
But that's the thing is the whole thing with standard refraction, it's affirming the consequence, bro. The whole reason you came up with standard refraction, and this is admitted in the geodesic manuals, you guys assume the predicted radius. So when you come up with standard refraction, you make it line up with the predicted radius. That's what standard refraction makes it line up with the predicted radius. It has never been demonstrated to be the case.
It has been. So you could say that we assume it today, but that's because we figured it out a long time ago. And regardless of whether it's affirming the consequent, as you say, which it's not, but whatever, it doesn't change the fact that it's just geometry. It doesn't look good on paper. That's just how it has to work. And it's not just because of standard refraction, it's just light in general. If light bends downwards, it lifts the apparent image. You can do this with lenses. It's not just the atmosphere. That's just how light works. It's not going to work differently because we're talking about the atmosphere.
If an object is looming higher than what's predicted by the radius, or is obstructed sooner than what's predicted by the radius, you come up with a refractive index to correct for that, and then you basically reverse engineer and affirm the consequence.
What's the difference to you between a reason and an excuse?
Deadline.
What's the difference between a reason and an excuse? What do you mean?
Because it sounds like you're saying these are all just a bunch of excuses, right? But if that's actually what's happening, right? If we're right about this, then they're not excuses, they're reasons for why we see what we see. So I'm asking, what's the difference to you between something being a reason something happens and just an excuse?
Well, you can have a hypothesis, right? A reasonable conclusion to why something is occurring and then you can correct for that hypothetically, which is what you guys have done, but you haven't actually demonstrated that through experiments. You have not. Nobody's done that. You say, "Oh, well, we did it in the lab." Dude, the lab is not. You can't do what you can't do that in the lab.
Absolutely, you can.
How?
Yeah, you can do it better in the lab because you can control for various factors. If you say that there's some hidden variable out there that we haven't accounted for, that's fine. But now it's on you to demonstrate that we've missed that. You can't just say there has to be something there that brings something back to planet.
We see inside of a celestial sphere. I don't remember the exact steps to the argument, but there is a thing that you guys are just basically throwing out and disregarding.
What's that?
As I said, I'm not really sure of the argument. Hopefully someone else will jump in who knows the celestial sphere, the sort of limits of optics of our eyes. This seems to be disregarded on the sort of globe model.
Yeah, the limits of optics of our eyes is at best angular resolution. Light doesn't stop working at a distance. We don't see things because light attenuates over distance. It attenuates due to distortion, obstruction, or diversion.
Yeah.
So light travels straight indefinitely unless it's
I was kind of asking myself the question before, right? Like if we exist inside of an electromagnetic field, which we do, and like gravity, which you attribute to the downward vector, is attributed to an electromagnetic field. Just like thinking, wouldn't the light as it courses horizontally through that field be pressed down, and that could just cause the bending of light itself? I don't know. Have you guys ever thought of anything like this?
It would very much depend on the mechanics of that electromagnetic field. Like there's an electromagnetic field, if you're talking about like the magnetic field of the Earth, maybe, but that's not going to do it. If you're saying that gravity is due to like electrostatics, I don't know if that would work in terms of bending light. But there's other reasons why we know that's not the case. Like gravity would work very, very differently if it were based on electrostatics.
Sure. Just a hypothesis for the second one. The first one still stands. I just don't know how to argue it.
Well, if someone can name the thing that we missed, I'm all too happy to hear the argument.
But you get what I'm saying, though.
For a bit.
With standard
I
refraction.
do, but so it sounds like sorry. Pardon me. It sounds like you're saying something is an excuse until it's been verified scientifically.
Yeah.
And as far as optics, I would say that we've very much done that. Newton was playing around with optics way back in the 1600s. And since then, we've learned a great deal more. Like all of these things that we've done in the lab are verifications of all the things we know about light and how light bends and how light travels and how things distort light and lenses and refractive indexes, et cetera, et cetera. Like we know these things.
Yeah, but when you're dealing with a chaotic atmos, right, with many gradient densities and evaporation and humidity and heat and particulates of pollen and dust, it's not, a controlled lab, dude. You know what I'm saying? Like it's not pristine or sanitized. You know what I'm saying? Like it's way too chaotic for you to come up with some number. Now, granted, there's an average refraction every day. There's an average standard refraction. I'll give you that. But it just happens that the numbers that you came up with just are there to fix it, right? To make it fit the globe radius.
No, that's where I disagree with you. So it's true that there's a lot of things happening, that the world outside the lab is chaotic and not as well controllable. But we can understand how humidity affects light. We can understand how temperature affects light, how density affects light. we can see the different ways that we can put those things together, and we can match that with what we're seeing out in the world. It's not just a post hoc rationalization. We're understanding how these things match what we already know about light. We can make approximations. There will be approximations unless we go out there and measure every molecule that's out there. But they're better and better approximations. And for those approximations to be so wrong that we've concocted a globe over instead of from flat Earth observation, like there's it's just not possible they're that far off.
All right, man. Well, you said you were leaving, right?
Yeah, I gotta make
I'm about to lose reception. So,
I can take over. Hello.
hey, Don, what's up? Good morning, my druid friend.
So my conclusion of the whole refraction conversation, at the end of the day, unless you want to make stuff up, there is obstruction at the horizon, just like if Earth was a ball. And you've got to integrate that somehow.
Yeah, the visual limits of your eyes. It's the collapse of the top.
No.
Yeah,
definitely not.
It's the ceiling crashing into the floor.
No,
that's
because
that's causing the limitation.
Then if we looked upwards, half the sky would be cut off, right?
What do you mean if you look
No,
upwards?
man.
If
No,
you're
it doesn't
saying
work like that, Don.
If it's related to the eyes, why does it only happen across one surface that we ever test?
Because the ground layer.
You're on one surface.
The
No,
ground.
but we can look upwards along a building wall. Yeah, look upwards across the wall of a building. Why doesn't half the sky cut off the bottom of our eyes?
What? What are you saying? Man?
What are you on about, Don, this morning? Coffee time.
You don't get
What's
that.
your premise?
You've asserted it's because of the eyes. That's why stuff appears like a ball. And I'm saying, so just stand upside down.
So what do you? How tall is this building?
It's not because of the eyes anymore. It's doing it the other way.
What are you talking about? A 40-foot building, dude? Like, what are you talking about right now? So if I'm standing next to a building and I look up, like, what do you expect to see? I don't get it.
I'm saying if Rick's assertion that it's to do with the bottom of our eyes, the limits, it was true, that would happen whichever direction we look, not just across the land.
No, because the light hits the land. There's no land, you don't have the same problem.
Have you ever dived into the ocean and looked down? Holy shit! Sometimes,
I disagree. I disagree with Rick's key for a different reason, and that's the test that Skyfree and Pebbles in the Pond have done. The one moment you can see the whole objects in the distance.
Right.
All observations. These observations were made with low viewpoint and small objects not far in the distance. And once you open a door or a window, cold air comes in and things disappear from the bottom up.
Interesting.
So it's not just limit of view. I think that argument is very wrong. The limit of view is mostly caused by atmospheric distortion and limits. through thickness and haze and things like that. Haze is reflection of light. So
who was the publisher of the footage or the evidence that you're referring to?
Skyfree and Pebbles in the Pond. Skyfree is a couple that have made many observations inside and outside with a very low viewpoint and objects not too far away. Model boats in a pond and small objects inside of the house. and pebbles in the pond that did that in some kind of barn or industrial complex, something like that. So the argument that the limit of seeing things above the horizon is because of the limit of our eyes, it's the limit of the thickness of the air just above the surface.
I do find it a bit curious, isn't it? Sort of the proportions of our eyes and what they allow us to see is directly relatable to the Earth itself.
What? How?
Can't remember the exact line of discussion that leads to that, but
How is it? You can't trust your eyes. That's how we know the Earth's flat. It's never been good, Rick. Got to come off that.
can't trust your eyes. I guess
Yeah,
is that your stillman of what I'm suggesting?
Yeah, that's my straw man of what you're saying. I've heard it from like 2020 on for 2 years. People were telling me I can't trust my eyes
What's the interpretation, isn't it?
because the eyeballs are round. It's making me think I'm on a globe. It's one of the worst arguments I've ever heard.
Trust your eyes.
It comes from fisheye, right? Because fisheye makes the horizon curve sometimes. It must have been invented to trick us into thinking Earth's a globe. And fisheye must be like our eyes. Balls create balls.
Well, it is one of the devices definitely used at high altitude to sort of give the presentation of a curve, right?
Dude, it's so dumb, dude. I just seen a video the other day of somebody debunking flat Earth. They sent a balloon up, dude. It was an incredible video, but it was curving before they even released the balloon. Before they released the balloon, dude, it had a crazy ill curve already, dude.
I saw that.
Yeah.
And they were like, "Oh, flat Earth debunked." I'm like, "You guys gotta be kidding me."
It was concave as well at a couple of points, I think, if it's the same one where the camera's swinging around a little bit. It went up above the horizon. It was clearly concaving.
You're stuck on that one. I gave it to you.
Before the balloon released the ground, dude, it was already curved. Unbelievable.
But you've heard that they still say there's a little area where if they catch it convex in that area, it still proves it. You've heard them say that?
What do you mean convex?
Like a globe, a planet. When it curves a bit at the right area of the fisheye lens, you can still say that's real curve.
There's a way to test for that. I forget how to do it, but you can actually, like, when it's concaving or when it's convexing, you can correct for that in Adobe, and you can see if it's actually flat or not.
No.
By the correction, yeah, you could see it, and
No.
yeah, dude, yeah.
No, correcting for it with extra distortion is not going to prove. Maybe if you're a nerd. I'm saying even with full fisheye, if you catch it convex at the right place of the lens for the right amount of time, you can still claim that's real curve.
Does it go concave though?
Yeah, on the even if it went concave at another point.
Well, that would just mean that the surface is being manipulated between convex and the opposite of which is concave, no?
Yeah, but in the middle of the lens, it still captures the real image.
It wouldn't though, because it would just be a point, wouldn't it?
Okay, forget my point.
Adobe,
You don't need it.
Adobe can correct for the distortion of the lenses, and when it corrects for it, you can see if it's actually flat. Now, if the Earth was round, when you would correct for the distortion of the lens, it would still be round.
Okay,
Do you
that's
have to
another way.
know, like Lion, do you have to know what the distortion of the lens specifically was before you plug it in, or can you take any footage and then it will sort of assess it and tell you what the distortion of the
No,
lens was?
you have to give it the model of the lens. Like
Okay.
Adobe has all the lenses and all that, camera, all that. So it already automatically will correct for the distortion. Like if you have a specific fisheye or something, you can input that fisheye in there, and Adobe will correct for the curvature of the fisheye. And when it does that, you'll notice that it's flat. But there's other ways to do it. I know Founded Earth Brothers, they have different methods of doing that. I forget exactly how, but
Don't they call it something like barrel distortion?
yeah,
that is
barrel distortion is one of them. Yeah,
that's the fisheye distortion.
I used to love fisheyes growing up, dude. When I used to skate, skateboarders love fisheye lenses.
Dawn still eats them. He loves them.
Or bikers, BMX riders.
Oh, Roohif finally took off. Okay. I appreciate the way y'all had the conversation with Refraction with him and finally got it broken down. I'm glad he finally said it. Y'all did hear it though, Lauren. You did hear him finally, right? He didn't know anything about no lab, anything about no ray testing of this stuff, and then he finally said it. Then he knew about it when he actually was breaking down refraction and trying to explain it. Isn't that funny?
So if you take a theodolite measurement of like an antenna, a radio antenna, the top, the blinking light of the radio antenna. If you make a theodolite measurement of that antenna, and you don't include any refraction index, like correction, it won't match the globe or the flat Earth for that matter.
Right.
It won't match. It won't match either. The height of it, as predicted with the curvature of the Earth, it won't match. So then they what they do is, well, according to the curvature of the Earth, it should be at this arc second or whatever, but it's not. So how much do we need to correct to make it fit the predicted radius of the Earth? And they'll be like, oh, well, you need to do 3 arc seconds up or down, right? 4 arc seconds, whatever, 5 arc seconds up or down. Boom, then it matches the radius of the Earth. And then they'll do it every day, the average every day, and they'll figure it out. This is how much correction you need to make it fit the radius of the Earth. And now the top of the radio antenna matches, but you have to correct. You have to correct for that.
Exactly, Liam.
And then after you do the numbers and you put the standard refraction, boom! Now miraculously it fits the radius of the Earth.
Miraculously worked. Yeah,
Now
I
it
was just trying to
works.
explain this to Alex that yes, they're using the radius of this just to calculate it to actually fit their damn model. And he was like, no. I was like, yes, I promise you, that's exactly what they're doing. I'm glad it was broken down the way it was today because they usually don't admit that earlier. So he did say, wasn't it 37? I'm trying to make sure I'm getting his information correct. So I'm writing this down. I'm going to forget what Roohif said. 37 meters is what he said they didn't allow for standard refraction, right? Does anybody remember? Was it 37 meters? I think it was.
The reason
think it
I'm
was
all
a
mellowed
30.
out is because I'm. Oh my bad. I'm just tired.
You're good.
I'm mellow right now. I'm tired.
Me too, actually.
I don't have the
Super
energy
tired.
to really raise my voice and get all amped and wired.
I'm getting amped because I'm irritated at Roohif instantly because he keeps doing this to me. Last time I talked to him, he's like, I don't know what you're talking about. I don't even know about what you're talking about. Next thing he comes in here, he's like, no, that's not true. Then he misses true. It's like, well, I don't. That's why I can't stand Roohif sometimes. And he'll chuckle, and you know that you're telling the truth. He's not. I don't understand why we entertain these people sometimes. But at
That's
least
not.
I guess we get the information from when they admit the truth here and there.
That's not correct. He's
I don't. Go on.
he's just
You're fine.
entertaining you by explaining what he knows. And that thing about in the lab is the index. Maybe
No
he's
shit.
never been asked that directly.
Oh no! I asked him if anybody was here, including Alex and Gio, who was here, and I asked him one morning all about this because I learned from a professor when I was over in the UK, and he was like, "Really?" And we talked about it and all this, the standard refraction. He said, "I've never heard any of this." He's full of shit. He told me to send him the paperwork on if I ever found that. He said, "I've never heard anything about a lab up to 200 meters or even 37. I don't know what you're talking about." He's so full of shit, hon.
So maybe he's looked since then, and that's why he said, "Yeah, I know
No,
now."
he hasn't. He knows about standard refraction. Did you not hear him saying? Didn't you hear my lecture I've given on that to somebody else? He definitely knows what the hell he's talking about and what we're talking about. He doesn't want to admit it. This is the issue. Real,
No,
actual people that
that's
actually
not
love the
correct.
earth and care about the earth, globe or not, will admit about refraction and this if they know anything about it. We have actually
Listen,
called refraction boys. Do you know what's
listen.
called refraction boys that we have in our community? They're not in Discord. They're on YouTube. They're called refraction boys. They're in the UK. They
You're
break
taking
down
it.
this shit constantly to people.
You're taking it as if he was a complete trickster and you were really honest. And
Absolutely, he's a
that is
trickster.
not what happened.
He's been doing it for years. He's an absolute trickster. It's Roohif. I mean, come on.
You got a bad taste.
Don, he's Satan's right hand man. What are you talking about?
No, you got a bad take. What you two and him totally disagree on what refraction is. You don't even agree there is such a thing that he's claiming.
That's not true.
So
Quit saying that
Ruhr
stupid
is
shit.
Satan's right hand man, and you're Satan's spawn.
Man, you can't.
What are we
Listen, we ain't gonna
supposed to
win
do
around
with you
here, honey.
guys?
Right, exactly.
I'll even give you that it's 50-50 for the sake of the conversation. So you're both tricksters.
Oh, now we're 50-50.
Yeah, both tricksters. But saying
Ooh,
it's
I
all
almost fell
him
again.
and not you, saying it's
Yep.
all him and not you, to me, I just find absurd.
Where's that ice? I don't know about y'all. We in Canada, and I can't even see out my window because we got so much snow. It's past the damn fence. Okay,
Hey,
we got bombarded.
Do you Globers like ever meet up? You guys have like meetups and stuff, or is
Yes,
that just
they
the
do
flat
sometimes.
earthers that do that?
I've never met a Glober. No, I wouldn't want to. Really.